Hi everyone, my name is Thomas. I work as technical partner at XRPL Commons, which is a non-profit based in Paris, and today's talk will be around XRPL, the oldest modern blockchain. So first thing first, this presentation is open source, which means that you can take any photos that you want. Please, if you want to use it in a later work, just tag us and use this license so we can keep open source stuff together. So this talk won't be as technical as the other one, so it's cool because it's the last talk, so we can crash a little bit. And because we want to talk about modern blockchain, what we want to do is first define and see where we come from. So this is a small history of blockchain, mostly layer 1s and layer 2s. And I grouped those based on what I would say innovation in a way. So it all starts in 2009 with Bitcoin, which is the first blockchain. I won't spend that much time explaining what is Bitcoin. And during Bitcoin and XRPL, there have been some chains that have seen the day, and most of those were Bitcoin forked at the time. So mostly during those 3 years, most of the new blockchain that come up were Bitcoin forked. There have been some very good ideas that went during this time of period, such as Namecoin, which were, I would say, blockchain for domain name. And then in 2012, there is XRP Ledger that is created. And this brings a lot of changes to the blockchain space. I will come back on this later. And then 2015, I think, is one of the most important year because it's when Ethereum is released. And Ethereum brings this idea of having a general purpose layer 1 blockchain, which is something fantastic because you don't have to have specific chain for specific needs. You can do everything in one blockchain. And then from this, a lot of other developers like this idea and then went to kind of explore the space of those general purpose blockchains, and that's where we have seen the wave of Ethereum killers, which was, I think, very interesting from a research and computer science point of view because it was trying to find new design and new ways to build those general purpose chains. Those chains could be account-based or UTXO-based, and the chains that come in top of the mind talking about those are mostly Cardano, Tezos, Algorand, Cosmos, Solana, and Polkadot. And so what was funny about that is that first you need to have like very good computer scientists to design those chains, but also have very good developer relation teams to onboard those people from the EVM to your specific chains. And what we've seen with the rollup-centric roadmap of Ethereum is that basically EVM was the global standard for programmability, and then that's when all those layer 2s came up to live on mainnet, which could be either optimistic or ZK rollups, those mostly being Polygon, Optimist, Arbitrum, Scroll, ZK Sync based Linear, and also Starknet, which is very interesting in a way that it's created a new VM specifically tuned for ZK Starks. And then in 2022, 2023, we have also those AdVM move based, mostly due to the fact that the team at Meta has been fired, and so they are continuing the project but on other company, and so that's Aptos and Sui. And then 2024 to now, we got those new big announcements during the summer, which has been the Stripe blockchain Tempo, Google blockchain Universal Ledger, and Arc from Circle. There is also new purpose-driven chain that are released every month or so, such as Katana. And I'm very happy that I found this comparative of those chains on Twitter. And there is mostly two things that very interesting there, is that all those chains are layer 1. And so why there is this design choice of using layer 1s is mostly because of finality and settlement. The fact with layer 2 is that you can have very fast finality at the layer 2 level, but you need to ensure that the settlement is made at the layer 1 layer. And so you want to have, when you are an institution, to have this settlement done. And so for, let's say, Bitcoin, you put the layer 2 on top of Bitcoin. You settle on Bitcoin, and then you have to wait the 6 block to be sure that the finality is there. And so you have your layer 2 finality plus the layer 1 finality. And this is not suitable for big enterprise-grade blockchain, or at least institution-grade blockchain. And they'll all have some specific features. So each blockchain is in a VM, at least for 2 of those, and all those blockchains are layer 1, and all those blockchains are built for a specific purpose. So Stripe is built for payments, Arc is built for stable coins and FX engines, so very aligned with Circle businesses around stablecoin. And Google Cloud, as it said, is universal, so it's kind of like general purpose, but general purpose for commercial bank and money on chain. And so from this particularity, we can kind of define what a modern blockchain is. And so the flow that we've seen with this small history of blockchain is that we're getting from general purpose chain to purpose-driven chain. And as I said, the early vision was one blockchain to rule them all. You had layer of programmability on top of your layer one, and then you can do everything that you want on top of it. But the reality is that each use case is an edge, and if you want to do custom logic there, it will be better to have this custom logic at the protocol level. And if you give sufficient load to this blockchain, it would be better than a general purpose blockchain, layer one or layer two. And so we can say that a modern blockchain is specialized chain for different use cases, gaming, DeFi, payments, stablecoin. Another very interesting fact is that we want high TPS and low finality. And this is achieved through what I called selective decentralization. And it's mostly come from the blockchain trilemma, which is that you have those three ideas of security, scalability, and decentralization, and you can't have those three on the same chain. This hasn't been solved yet. There is nothing new under the sun. And for institution, finality is very important. And so to have a subsequent finality is made through the consensus, and you can also scale through the consensus. And so based on your blockchain trilemma, you will kind of like lower decentralization and have those two very important stuff that are the finality, security, and scalability. And you will decentralize your blockchain through the institutions that are part of your consensus. So most of those chains will run something like proof of authority, and the idea is via game theory, you onboard big players into your POA, and so those big players don't have any economic interest of playing around and trying to do weird stuff with your consensus. And so you decentralize that through the big institution that you onboard on your chain. Another very important stuff is that we have DeFi at the protocol layer. So liquidity fragmentation is one of the biggest problems we have with layer twos. There is a lot of research and very, I think, interesting companies that are building on solving this problem. And so most of the new blockchain basically have those AMM, lending, borrowing, central limit order book at the protocol level. Thinking about Katana here, which is a DeFi specific purpose chain built by Polygon. And the idea is that this allows to avoid the fragmentation of liquidity on your blockchain. You can also add custom mode at the protocol level, and this ensures more compliance than what you might have with, I would say, a rule at the smart contract level. And also, most of the chain now want to protect users from MEV. So MEV is the idea that you can order transactions in a certain way that you can make money on different trades because of the mempool and so on. And so these harm users. I think nobody in the room likes to be sandwiched and lose 2 or 3% on the swap. And modern chains have built-in MEV protection. This could be encrypted mempool and stuff like this. And the idea behind it is that a user-first economic is better because it's fair and it allows predictable execution. Also, we want to have programmability. Why we want to have programmability is because developers need flexibility. And the idea is that if you give a lot of people programmability, a lot of people have very good idea, and a lot of people can innovate on top of your layer one. And the EVM has been the global standard for this. Most of the blockchain space that we live around today is fingerprinted by the EVM. AMMs are being built on Ethereum first, and so on. And every one or so, there is like a big new app that's come on an EVM chain, and then the liquidity follows. So to put it in a nutshell, this is what we could say a modern blockchain is. So it's a specific purpose chain with ITPS, instant finality, built-in DeFi primitive, MEV protection, and programmability. So this is what we have in 2025. Now, if we look back in 2012, what do we have? Well, it all started with the limitation of Bitcoin. So in 2011, we have this post on Bill Code Talk which have been made by Jeb McCaleb. And the idea behind it was that Bitcoin was very cool, but it was limited in a way that the consensus was using a lot of energy to do, I won't say nothing because it's not that, but it was kind of unenergy efficient. And the idea was to have a blockchain that kind of gets out of this POW world and try something new. And so in 2012, this blockchain launched, which was the XRP ledger. And the idea of it was to address limitation for crypto and fiat currencies, for financial use case and specific payment. And in 2012, it was very interesting because it was one of the first blockchains that launched without being a Bitcoin fork. So all the Bitcoin forks that based on UTXO model which is not suitable for big financial use cases. And so it was the first blockchain that launched on an account-based model, which is the standard in the industry right now. Ethereum is account-based model, Solana is account-based model. Most of the chain are on an account-based model. Also, the consensus wasn't proof of work, which, as I said, most of the chain were Bitcoin fork, so proof of work consensus. And so it was designed for reliable sub-second finality. So finality is at the block time, which is 4 seconds. It was very energy efficient because there were no proof of work. And so this supports institutional grade use case. The most interesting thing, I think, was that in 2012, there was a built-in DEX at the protocol level. So it launched with a central limit order book, which is mostly what you all use on centralized exchange. And meaning that it was a central limit order book, it also means that it was able to, you were able to issue coins in 2012 on the chain. And so it was this idea of DeFi before the DeFi, where we can be able to trade USD for GPY, for Euro, and so on chain, through another book, which, again, is not the best solution where there is low liquidity and so on, but it was the beginning of this idea of having DeFi at the protocol level. And last but not least, there is no MEV on the XRPL. Why? Because there is no incentive to validate the network. So when you are validating the network, you can't get any money. And so there is no incentive for block builder to rearrange the block and so on. And so the MEV is based on a thing called canonical ordering, which is this idea of that if you take a block, there is a list of transactions. Those transactions are encoded through a specific algorithm, and then you just sort those. And so you can be sure that your transaction will be before or after, thus making MEV very complicated on the chain. So we have seen what is launched, but it's also launched because it was purpose-driven, which was for financial institution. And at the time, it was before Ethereum, so there wasn't this idea of smart contracts. Idea of smart contracts came in 2013, at least the Ethereum white paper. And so it was a fixed function ledger, which means that if you want to send a payment, you have a method called payment and you sign a payment. If you want to place an order, you create an order and so on. And so all the functionality that you had are at the protocol level, which is very strong because if you want to swap a token, it's the same security aspect as sending a token. So imagine you're on Ethereum, you want to swap USDC to ETH, it will be at the same level as just sending ETH to another address, which make it very secure and also make it very cheap because there is no computation at the VM level. And still today, there is no native smart contracts. There is an effort made by the core developer to add smart contracts through WebAssembly VM. Why WebAssembly and not EVM? Mostly because EVM wasn't suited to be on top of the chain. So it's a very different engineering problem than creating a new chain with a new VM, is that we have a chain that is worth $200 billion and you want to plug something that allows programmability. And so you are under constraint of this chain that already existed for 13 years. And also it's focused on simplicity because it's a fixed function ledger for a developer to use it. It's very easy, mostly API calls similar to what you might have on Web 2. And this also allows to have very predictability on the transactions. The core features are interrogating at the protocol level. So as I said, it's allows you to have very secure features, but also there is a big gap there. It's because you always lag behind the chain that has a VM in a way that innovation is mostly made on Ethereum, and then it's ported to XRP Ledger because it required an amendment, which is similar to an EIP. And so if you want to add NFTs, you will have to spec NFTs on the chain, validate it through the community, and then implement it. So that's why there is, I think, a lack of R&D, and that the chain has missed, let's say, the DeFi summer. It's because it was always lagging behind the innovation that has been made through the EVM. Today, this chain is the third by market cap. It's fairly continuous innovation. There is a release every month. It's expanding to RWA. Stablecoin are starting to be onboarding, and we've launched an EVM sidechain at ETC. Why a sidechain? Mostly, as I said, because it was easier to create a new chain that uses XRP to run gas computation than plugging an EVM on top of the chain. Yeah, and so if we get through this through a modern lens, it is very modern in a way that we tick 4 out of the 5 boxes that we have. So it's purpose-specific, ITPS, built-in DEX, MEV protection through the canonical ordering, but there is no native programmability. And so the trade-off is that you have something that is very easy to use, very reliable, but as you are missing most of the new innovation that come through programmability, you always lag behind competitions. I will end this talk by inviting you, if you want to learn more on and get your hands dirty, to the workshop that I will be giving tomorrow from 11:30 to 12:30. So this will be hands-on XRPL. So the idea is that I will just show you how to code some application on top of it. It's very easy. It won't be as hard as doing TE or ZK. So if your brain is kind of overloaded, this is a good workshop because you will be able to do something in an hour that won't require you to work at home after. And yeah, that's it for me. Thanks a lot to have attended this presentation. I think we have time for Q&A.
Yep, definitely. So, do we have any questions?
Yep. This one?
MEV protection through canonical ordering?
Okay, so the idea of MEV is that you need to mostly work with the block builder to sandwich, right? And so this means that the block builder has an incentive to sandwich you. Here on XRPL, the block builder doesn't take any fees. Fees are burnt. And so the thing of giving money to the block builder to sandwich someone is something dumb in a way that you can't ensure that your transaction is first before the other. So this is the first thing. The other thing is that in a block, the transactions are ordered through a specific algorithm. And so let's say you made a payment, I create an NFT, and someone placed an order on another book. Then those three transactions will be, let's say, hashed in a way. And based on the hash, it will be ordered in the block. And so you can't be sure that your transaction will be after or before the transaction you want to MEV. And so you can't MEV. Or you can try to MEV, but you have no security that during the transaction and when it will be settled on the block, you will be able to MEV. I mean, you can front run also. So, I mean, sandwich is front run and back running. So you can construct a sandwich because there is no front running and back running. And other type of MEV, I don't know what you have in mind.